Hello everyone. Let's solve this problem, sleeping schedule, right? So let me summarize this problem for you guys. So basically what they're asking to do is, so here the problem mainly involves determining the maximum number of valid segments we can get from the array of integers. So again I'm telling, you can read this entirely. So I'll just summarize it for you guys. So what it is saying, the problem involves determining the maximum number of valid segments. So we have to determine the maximum number of valid segments that we can get from array of integers. So array of integers where each segment is defined by specific conditions related to modular arithmetic. So each segment is defined by specific conditions. So they are saying each condition is defined by specific conditions related to modular arithmetic. So the segments are considered valid only if their length and starting position meet the certain criteria. So again I'm telling the last sentence, the segments are considered valid only if their length and the starting position meet the certain criteria. So that's what they have given here, this one. So our main task is to say the maximum number of good sleeping times this one Vova can obtain if he acts optimally. So you can completely read this one. I have summarized the problem as well for you. That will be easy to understand basically. So what would be the approach that we are going on? So let's define this one. Let's define the solution approach step by step. First, what we will be doing, we'll be making use of the JavaScript or the Node.js. First thing will be what we will be doing is we'll be going with the input handling. That one is first thing. Next, we have to understand the problem. Means we are given an array A, right? We have been given an array A and the range L comma R. Nothing but here. Range is nothing but here. L comma R. We have been given an array A. I can just simply write this one. Array equals A. We have been given array A and the range R equals and the range L comma R. So what we need to do, we need to find the maximum number of valid segments where the sum of segment elements modulo H falls within the range L comma R. We have to find the maximum number of valid segments where sum of the segment elements modulo H, this one modulo H has to fall within the range L comma R. So this has to fall, modulo H has to fall within the range L comma R. So we have to find the maximum number of valid segments, right? So this is second thing. Next, we are going with the dynamic programming array. We will be making use of the dynamic programming approach to keep track of the maximum number of valid segments that we can achieve. So we'll be going with the DP, right? So also the next step will be going with the iterative calculation. Nothing but we are iterating over the array to update our dynamic programming array based on the current segment's validity. So this is nothing but iterative calculation, right? Finally, the final step is we will be outputting the results. That's what we'll be doing. So let's write the code and try to understand it, right? So just give me a second. So yeah, I'll just come here. So yeah, just give me a second. First, what we will do, input handling is same for most of the problem. So if you have followed the previous problem, you'll be knowing how to handle the initial input handling, right? This will mostly be same for most of the problem. First, what we'll do, we'll set up the input handling for the script. So I'll just give what we have done here. We are activating the standard input stream to read the data. Next, we will set the encoding for the input data to UTF-8. How can we do this one? I'll just give standard input encoding of UTF-8, this one. This is fine. Next, let's initialize a variable to store the entire input data as a single string. As usual, I'll be giving input or the input string we can take. I'll just give input string this time. Let's initialize this one to the empty string. Also, let's initialize the counter to keep track of the current line number. So either we can give let line or I'll just give current line. This input handling will be same for most of the problem. So next, let me give process standard input on this one data. Let me call the input string or input. This has to be, nothing wrong, just give me a second. This has to be, yeah, standard input. This is fine. Let's call the input string equals input string plus input standard. So what we are doing in this step here, we are just appending each chunk of the input data to the input string. Next, just give me a second. So next step, what I'll do, I'll just come here, process, same thing. Let me copy this one and make the necessary changes instead. This one will be same thing. Instead of data, I'll just give end. Sorry. So here I'll remove this one. This one has to be input string equals input string itself. I'll just make use of the trim. So let me give trim. Why we are making use of the trim? So to remove this one, right? White spaces, nothing but to remove the white spaces or the space from the input string, we'll be making use of the trim. Next, I'll just make use of the split to split the input string into the array of lines. I'll just give split of /n. We need the output in different lines, right? Individual lines. So I'll be making use of the /n, split of /n. Then let me give map. I'll just consider within this one string. Let me make use of trim again. Sorry, this is fine. So what we are doing here is why we have made use of the map and calling the string inside. So we are trimming each line to remove the extra spaces. We don't need the extra space, so we are trimming each line to remove the extra space. So after this one, we have to call the main function here itself. We have not written the main function yet, so we'll be writing that one in future. Once I write the main function, I'll call the main function here. So next, let's make use of the helper function to read the next line of the input. We have to individually read every line of the input, right? For that purpose, we'll be making use of the read line. I'll just give function here, read line. Just come here. Yeah. This one has to be read line. So let me give here return input string of current line. So we are incrementing this one, right? So what we are doing in this line, we are just returning the current line and we are incrementing the counter. So we have to move to the next line, right? So we have to read the individual line and we have to move to the next line. So that's what we are doing with the help of the helper function here. Next, we will write the main logic in the main function. So I'll just come here. I'll just give function main. We'll always write the main logic in the main function, right? First, what we will do, we will read and pass the first line of the input. How can we do that? I'll just make use of the let. So this is easy. Let's make use of the destructuring operator. I'll just call n r. This one I'll just give read line split. We need space, right? I'll just leave the space here. Map of number. So this is one thing. So what we are doing here, we are getting n, h, l and r as numbers. So we are destructuring this one, right? We are getting n, h, l and r as numbers. Next, we will read and pass the second line of the input. How can we read and pass the second line of the input? I'll just take another variable. I'll just call this one a and I'll just give read line. Again, I'll just make use of split. Let me leave the space here. Map of, I'll just give, in simple terms, I'll just give number. So we are getting array A as numbers. Next, we will write the function to check if a number x is within the valid range after the modulo operation. After performing the modulo operation, we will we'll write the function to check if a number x is within the valid range. Again, I'll just make use of the let f equals x l less than or equal to x. We are performing modulo operation, right? Mod h and x h. This one. This is fine. Less than or equal to r. So this is one thing. Next, we will initialize the variable to keep track of the cumulative sum. Nothing but I'll just give current, or I'll just give current equals 0. CUR, I'll just call the variable name. Next, we'll initialize the DP array to store the maximum number of valid segments. So while explaining initially the approach, as I've said, we'll be making use of the DP array to store the maximum number of valid segments. That's what here I'm doing. I'll just initialize the DP array to store the maximum number of valid segments. I'll just give let DP new array of n plus 1. I'll just fill this one initially with 0. Or you can do one thing. You can make use of this one as well. What do I call? Typed arrays as well. That will be actually it'll the memory efficiency. While we make use of the typed arrays, usually the memory efficiency will be more. So you can go with the typed arrays. I'll just go with the normal this thing, array initialization. So what we have done here, previously we had initialized the DP array to store the maximum number of valid segments. After this one, I said while explaining the approach, we'll go with the we'll iterate through each element in the array, right? For that one, I'll just make use of the iterative calculation, nothing but I'll just make use of the for loop. For let I equals 0, I less than n, this will be I plus plus. So current initially we had initialized this one to 0. I'll give current is equal to current plus a of I. This is one thing. This line, what it says, what we are doing here, mainly we are updating the accumulating sum by adding the current element, nothing but a of I. Current equals current plus a of I we are doing. Next, what we'll do, we'll update the DP array for the current element. I'll just come here. Let me make use of the for loop. Let j equals I plus 1 I'll give. J greater than or equal to 0. Also decrementing the j. So this is one thing. We'll update the dp of j by considering the previous state. Nothing but dp of j minus 1. So how can we do that? I'll just make use of the if condition for this. If j is greater than 0, what I can do, I'll just give dp of j here. I'll make use of, we need the max value, right? I'll just make use of the mat.max. This has to be caps, sorry. Just give me a second. This has to be caps. inside here dp of j and dp of j minus 1, nothing but the previous element. So this is fine. In the next step, we will be checking if the segment is valid. If valid, we will be updating the dp of j. Again, I'll be making use of the if condition. Now, if L less than or equal to current minus j. Oh, this one, just give me a second. So yeah, here this will be till h. And this one, current minus 1. Sorry, this has to be current minus j, right? Module h. So this has to be less than or equal to r. Then dp of j equals dp of j plus 1. That's what we are doing here. This is simple to understand. So the next what we will do, we will output the maximum value from the dp array. Finally, actually we need the maximum value itself, right? So in the output. So to get the maximum value, we'll be making use of the mat.max of dp. We can just make use of the spread operator. And finally, to display that one, we'll be making use of console log. So I'll just give console log of, we need the maximum value. So I'll just make use of the mat.max spread operator dp. So here this one, right? dp. So this is it. Let me, here, after this one, let me call the main function here. So this is one thing. I used to forget this one every time. So let me come here. Let me copy the input. Output has to be 3. So let me give the input over here. Let me run this one. So we are getting something, right? The readline.split is not a function. Line number 22. Just give me a second. So here what I have done in the line number 22, I have forgotten the braces, right? So let me hit the run again. So we are getting the output 3 here. So output should be 3 and we are getting the output 3. Just give me a second. So I'll just come here. Let me come to, this is E, right? Problem E. Sleeping schedule. Let me paste the solution over here. So let me submit this one. Let's wait for some time, right? So yeah, this got accepted, right? So clearly you can see. So this code works absolutely correct. So this is it. Thanks for watching, guys.